Good evening, class. We are back with part 2 of the long division algorithm. We started this yesterday. I think we'll probably do one more. There'll probably be a 3-part series here learning the long division algorithm. And as you'll remember, it took quite a bit of practice just because a lot of stuff has to go in just the right place. And so it's nice that we have a few different situations because it still lets us practice the part that's similar. So yesterday we worked on problems like this with the long division algorithm. Let me erase this. And so just as a quick reminder of how it worked, if you want to think along with me, this is the partial quotient way I did it 2 days ago. That if I divide out, come on, pen, go. So I set that up like this, right? I did 973 divided by 3. And just as a quick review of how it works, so I'm looking one digit at a time, right? So the first thing I'm doing is I'm saying how many sets of 3 can I do to make 9? How close can I get to 9 without going over? And I can actually get to 9 exactly with, I can do 3 times 3, 3 sets of 3 to make exactly 9. Write that product down there. And then subtract the 9 and have a 0. And then once I've dealt with the 9, I deal with the 7 next. So now I'm looking down here at this, not at this, at this. I'm asking how many sets of 3, how close can I get to 7 with sets of 3 without going over? And the answer is that I can make 2 sets. I can do 3 times 2 is 6. If I were to do a third set, I would have 9. That's too many. So I can subtract my 6 from my 7, and I have 1. Now that I've dealt with the tens place, deal with the ones place, bring that 3 down. And how close can I get to 13 with sets of 3 without going over? And the answer is I can do 4. 3 times 4 is 12, close to 13, but not going over. And I had 1 left. And remember, the way we've been dealing with this remainder is saying, all right, well, I can make 324 groups of 3, and I have 1 out of the next set of 3 left, 324 and a third. All right, so that's what we did yesterday. So I want to go to, you'll remember when we did our I-dos and such, we had 2 problems. So there's on the left the one we just did. And then when we did this with partial quotients, we also had an example next to it. So I say I'm going to try this 284 divided by 4. And let me show you why that's different, why this is worth a second lesson. It's a little bit of a different situation because yesterday our divisor always went into that first digit of the dividend. But now it doesn't, right? Here I could always say how many sets of 3 can I use to get 9, and I could make 3 sets. Here I can't make any. Say 4, well, how many sets can I do to make 2? Well, actually, I can't really do any. Let me show you 2 ways you can handle that, and you can do whichever one makes you more comfortable. The first way is I can just do like I would have done yesterday and just say, well, really the best I can do is 0. If I even do 1 set, I'm going to have too many. So I'm going to do 4 times 0 is 0. And just follow yesterday's steps and do 2 minus 0 is 2. And bring down my 8. And now I can say, well, 4 times what? How close can I get to 28? So I think I can hit it exactly with 4 times 7 is 28. And get it exactly. Take that away. 0. Move on to my 4. And I can make exactly 1 set of 4 to make 1. And so my answer is 71. 4 times 1 is 4. And no remainder. So that's one way. If the first digit won't work, just put a 0 there. And if 0 is the best you can do, 0 is the best you can do. I can save you a step if you want, a shortcut. Same thing is if 4 won't go into the first digit, which here it won't go into 2, then I can just look at the first 2 together. And say, all right, 4 won't go into 2, but how many times will 4 go into 28? And just as we found last time, it'll go in 7 times. 4 times 7 is 28. So that's just a little shortcut. Instead of doing 2 steps, I get this 7 in the tens place in 1 step, if you want to do it that way. Either way is okay. Again, this is all about finding out what you're comfortable with. And then 4 times 1 is 4. No remainder. All right, let's do one together. I'll do them both ways in the we do. You can decide if you want to write both down or one down. So here's how we did it with partial quotients. And so this was a word problem, I said, right? A wonderful donor bought 475 expo markers for 4 fifth grade teachers. How many did they get to share? And they got 118 and a weird 3/4 of a marker. I said, oh, wait a minute, let's make that 275. So they only donate 275 for 4 teachers. I'm going to get that situation again where I cannot make a 2. 4 won't go into 2. So I showed you 2 ways to deal with that. And you can kind of pick your favorite here. The first way is to just say, all right, well, the closest I can do is no sets. So I'm just going to put a 0 there and say 4 times 0 is 0. Subtract. And now work with my 7. And let's see, 4 goes into 27. 6 times 4 is 24. 7 times 4 is 28. That's too many. So it looks like I can make 6 sets in my next place. 6 times 4 is 24. 3 left. Bring down my 5. And let's see, 4 times 9 is 36. Too much. So 4 times 8 is 32. And I'm left with 3. There are no more places. There's nothing to bring down. So I just stop there. So I've got a remainder now. And so I'm dividing into groups of 4, right? So I've got 3 out of my next group of 4. And so same as over here, I wouldn't really give every teacher 3/4 of a marker. In this case, what that remainder means is everybody gets 68 markers, and 3 of the teachers could have a 69th marker, and 1 teacher would just have 1 less. So that's the way to do it if you want to have a 0. I can save you 1 step if you want. Your other option will get the same answer, of course, because it's just another. This is just sort of a cut a step out if you're comfortable with this already, is to say, well, if 4 can't go into 2 at all, then look at the first 2 digits. That's only if it can't go in at all. Since it can't go into 2, I'm just going to look at 27 altogether. And as we remember last time, I could do 6 sets. 6 times 4 was 24. We did a 6 times 4 was 24 last time. We just did it 1 step later down here, if you'll remember. So I'm just saving myself 1 step if you want. 6 times 4 is 24. That leaves me 3 after I subtract. And 4 times 8 was 32. There's my remainder of 3, 68, and 3/4 of a marker. All right. That is it for day 2 of the division standard algorithm. After you finish writing your example down, whichever method you prefer, we will finish up tomorrow.